if I had a stator like this and I applied a single phase supply to it, then on the positive half cycle the current would flow through the windings, and that would give me a north pole here and a south pole here, flux lines running in this direction. Then on the negative half cycle the current would flow in the opposite direction, and therefore the flux lines would be in the opposite direction. So our north pole will have switched to this position and the south pole will be switched to this position. Now if I put a piece of copper or aluminium strap across these points here, I get a shaded pole, and what the shaded pole motor will do is it will create a magnetic field that rocks around the stator. So how is that accomplished? Well, let's look at the current and let's take some times. So time 1 to time 6. And the principle is based on flux lines in the stator here cutting the conductor, so that will induce some current in this conductor here. And the whole thing with induction is it depends on the rate of change of flux. Okay, so if we have current increasing and decreasing here, we can say that the flux is also increasing and decreasing in the stator. If we want to look at the rate of change of flux, we will get the derivative of it. So we differentiate this equation and we'll get something like that. And then really the induced current will depend upon the inverse of the derivative. This is due to Lenz's law, so it'll be the negative. So basically it's this graph here that will determine how much current is induced in these straps. So let's compare both. So at time equal to 1, there is current going through the winding here in the red, so we get a north pole here and a south pole here. Now at this time there is also a change in flux, so there will be a current induced in this strap. Now this current, according to Lenz's law, the direction of it will be as to oppose the cause. Okay, hence the flux around this shaded ring will oppose the main flux. Okay, so if I had a north pole here and a south pole down here, the flux lines around this shaded part will oppose the flux out here, and therefore all the flux lines will move towards this part of the stator, and consequently the south pole will move to this side, and we'll get our flux lines in that direction. Now at time 2 the current is at its maximum, but if we take the derivative of that, it means the change in flux at this point in time is 0. So if there's no change in flux, that means there's no current induced in here, and if there's no current induced in here, then there's no flux around this to oppose the change. So the flux lines will be as they were normally, right? Just straight down, north to south. So the north pole has moved from here to this point. Then at time 3, well, now we can see that the current is decreasing and hence the flux is decreasing. Okay, but the change in flux is in the opposite direction. It's increasing. So what's going to happen here? Well, we'll induce a current here, and it's going to oppose this decrease. So what we're going to get is the north pole and south pole around the shaded pole is going to add to the north pole and south pole due to this part of the current, and all the flux lines then will be more concentrated in this shaded pole part. So the flux lines will run in this direction. And similarly on the negative half cycle, here the current is negative, so we're going to get our north pole here and our south pole here, but there is a change in flux that's going to cause a current to flow in the straps, and that's going to oppose the change. So we're going to get a north pole opposing the north pole by these windings. We're just going to call all the flux maybe to concentrate in this area, so the flux lines will run here. Then at time 5, the current is at its maximum in the opposite direction, but the change in flux is 0, therefore no current is induced in the strap, so the flux lines will run there, and finally 6, they'll go in that direction. So we can see that the flux lines have moved around the stator, and we call that a rocking magnetic field. So if you have a rotor that can follow that rocking magnetic field,